It's safe to say that most people who use statistics are more familiar with parametric analyses than non-parametric. Non-parametric tests are also called distribution-free tests because they don't assume that your data follow a specific distribution. You may have heard that you should use non-parametric tests when your data don't meet the assumptions of the parametric test, especially the assumption about normally distributed data. That sounds like a nice and straightforward way to choose, but there are additional considerations. In this video, I'll help you determine when you should use a parametric analysis to test group means and when you should use a non-parametric analysis to test group medians. In particular, I'll focus on an important reason to use non-parametric tests that I don't think gets mentioned often enough. Let's begin with the definition of parametric. A parametric test is a type of hypothesis used in statistics to generate data for the primary original population's mean. The t-test is performed using the t-statistics of the pupils, which is frequently utilized in that value. Now, why and when you should use parametric tests? First reason is that parametric tests can perform well with skewed and non-normal distributions. This may be a surprise, but parametric tests can perform well with continuous data that are non-normal if you satisfy the sample size guidelines in this table. These guidelines are based on simulation studies conducted by mathematicians of Minitab. So when you use one sample t-test, make sure that the sample size is greater than 20. Two sample t-tests wherein each group should be greater than 15, and one-way ANOVA if you have 9 or 2 to 9 groups wherein each group should be greater than 15. If you have 10 to 12 groups, each group should be greater than 20. Second reason is that parametric tests can perform well when the spread of each group is different. While non-parametric tests don't assume that your data follow a normal distribution, they do have other assumptions that can be hard to meet. For non-parametric tests that compare groups, the common assumption is that the data for all groups must have the same spread or dispersion. If your groups have a different spread, the non-parametric test might not provide valid results. On the other hand, if you use the two-sample t-test or one-way ANOVA, you can simply go to the options sub-dialog and uncheck Assume Equal Variances. And then voila! You're good to go even when the groups have different spreads. Last reason is that parametric tests usually have statistical power than non-parametric tests. And thus, you are more likely to detect a significant effect when it truly exists. Now, let us have the reasons why or when we are going to use the non-parametric test. The non-parametric test does not necessitate any population distribution, which is what different parameters refer to. It's also a type of hypothesis test that isn't based on the hypothesis at hand. The first reason in choosing a non-parametric test is that the area of study is better represented by the median. This is my favorite reason to use a non-parametric test and the one that isn't mentioned often enough. The fact that you can perform a parametric test with non-normal data doesn't imply that the mean is the statistic that you want to test. For example, the center of a skewed distribution, like income, can be better measured by the median where 50% are above the median and 50% are below. If you add a few billionaires to a sample, the mathematical mean increases greatly, even though the income for the typical person doesn't change. When your distribution is skewed enough, the mean is strongly affected by changes far out in the distribution scale, whereas the median continues to more closely reflect the center of the distribution. For these two distributions, a random sample of 100 from each distribution produces means that are significantly different, but medians that are not significantly different. Second reason is when you have a very small sample size. If you don't meet the sample size guidelines for the parametric tests and you are not confident that you have normally distributed data, you should use a non-parametric test. When you have a really small sample, you might not be able to ascertain the distribution of your data because the distribution tests will lack sufficient power to provide meaningful results. In this scenario, you are in a tough spot with no valid alternative. Non-parametric tests have less power to begin with, and it's a double whammy when you add a small sample size on top of that. And for the last reason, when you have ordinal data, ranked data, or outliers that you can't remove. Typical parametric tests can only assess continuous data, and the results can be significantly affected by outliers. Conversely, some non-parametric tests can handle ordinal data, ranked data, and not be seriously affected by outliers. Be sure to check the assumptions for the non-parametric test because each one has its own data requirement. Now here are the hypothesis tests of the mean and the median. You see, non-parametric tests are like a parallel universe to parametric tests. This table shows related pairs of hypothesis tests. If we have one sample t-tests under parametric test, we have one sample sign or one sample Wilcoxon under non-parametric test, two sample t-test for parametric test, Mann-Whitney test for non-parametric test, one-way ANOVA for parametric, Kruskal-Wallis and Moods median test for non-parametric test. We have factorial DOE with one factor and one blocking variable for parametric test and Friedman test for non-parametric. So it's commonly thought that the need to choose between a parametric and non-parametric test occurs when your data fail to meet an assumption of the parametric test. This can be the case when you have both a small sample size and non-normal data. However, other considerations often play a role because parametric tests can often handle non-normal data. Conversely, non-parametric tests have strict assumptions that you can't disregard. The decision often depends on whether the mean or median more accurately represents the center of your data's distribution. If the mean accurately represents the center of your distribution and your sample size is large enough, consider a parametric test because they are more powerful. If the median better represents the center of your distribution, consider the non-parametric test even when you have a large sample size. Finally, if you have a very small sample size, you might be stuck using a non-parametric test. Please collect more data next time if it is at all possible. As you can see, the sample size guidelines aren't really that large. Your chance of detecting a significant effect when one exists can be very small when you have both a small sample size and you need to use a less efficient non-parametric test.